Welcome to Buckeye Turf Podcast. This podcast provides a brief overview of irrigation. My name is Carl Danneberger, Professor of Turfgrass Science here at The Ohio State University. One of the most difficult decisions a golf course superintendent will make is when, how, and with how much water to irrigate with. Depending on the location, concerns of water availability and quality will also influence irrigation practices. In temperate, humid, climatic regions, nature's role is an important consideration in irrigation because nature impacts irrigation by providing not enough water or too much. And thus how a golf course is designed to handle excess moisture through drainage, both surface and subsurface, is important in an overall irrigation program. From an irrigation perspective, we will look at water sources, irrigation components and systems, determine water requirements, and methods for identifying moisture deficits. A major source for irrigation water is underground wells. The water source for this pumping station is located 100 or more feet below the surface. In the previous photograph, the pumping station was exposed, but in most cases the pumps are in a protected pump house for reasons that will be discussed later. Irrigation water can also be pumped from streams, lakes, or ponds. In Ohio, for example, 32% of the water used for irrigating golf courses comes from lakes and ponds, 26% comes from wells, 13% from streams, and 15% is a combination of the previous sources mentioned. Less than 14% comes from public water. Increasingly, effluent water is being used as an irrigation source for golf courses for several reasons, including environmental reclamation efforts. It is the only source allowed for irrigating turf by municipalities, and the close proximity, relatively speaking, of golf courses to water or sewage treatment facilities. Wastewater treatment consists of three stages: primary, which is the removal of solids; secondary, which removes organic impurities; and tertiary, which is the further removal of impurities and considered the highest level of treatment. Tertiary is the primary effluent water source for golf courses. Effluent water is brought directly to the golf course and deposited or blended with natural or potable water in irrigation ponds. In some instances, however, effluent water is applied directly to the turf through the irrigation system. The main pipe shown here runs from the sewage treatment facility directly into the irrigation pipes located in the pumping station. Effluent water sources need to be monitored and regularly tested to evaluate the suitability for turf use. This is an example of the types of tests and recommendations that might be found on a water test report. Frequent use of effluent or any water high in salts can cause injury to the turf, as shown here. Symptoms of salt injury look similar to drought injury, with leaf firing a common leaf symptom. Periodic leaching or heavy irrigation is required to wash or move salts down through the root zone. Salt injury from effluent water use can occur to landscape plants. Effluent water applied through the irrigation sprinklers around this tree caused the salt injury. Irrigating with effluent water should be closely monitored to make sure the water is not applied to non-target landscape plants. Once the source of water is secured, the water needs to be extracted from the source, in this case a pond, and moved into the irrigation system. Where the pump or pumps are located is known as the pumping station. A pump house protects the pumps from the environment and for security reasons such as reducing the risk of vandalism. The primary turf irrigation pumps contain an impeller that produces the needed pressure through centrifugal action. There may be 1 to 3 pumps at a pumping station. A smaller pump, sometimes termed a booster or jockey pump, and then a pump or two with increasing horsepower. For example, including the booster pump, the pumps may be 25, 50, and 75 horsepower. The types of irrigation systems are automatic, semi-automatic, and manual or a quick coupling type system. Automatic systems are comprised of pop-up heads that are automatically activated by valves that are triggered from a computerized satellite on the golf course or a master control box. The advantage of the automatic systems is that they can be programmed to activate sprinkler heads at a specific time and for a given period without being physically present. Semi-automatic systems require a manual operation to activate the valve turning on the system. In some cases, semi-automatic may refer to the greens and tees being automatic and the fairways on a manual system. The last type of irrigation system is termed manual, which uses quick coupling system. A manual system consists of a quick coupler valve that is attached to the irrigation pipe, a quick coupler key, and a rotary sprinkler head. The sprinkler is commonly an impact rotary. The quick coupler key is inserted into the valve and turned with the handle, activating water flow directly to the sprinkler head. In this case, the quick coupler key is attached to a hose where the water is being hand applied. As a note of caution, when using a quick coupler, do not place your head or any part of your body over the quick coupler. When the quick coupler key is turned, water is released directly up into the sprinkler, and the potential exists that the sprinkler or water attachment may break, allowing water to rush directly up into one's face or body, causing serious injury. As one golf course superintendent told me, don't look down. In other words, when turning the key, place yourself at an angle away from direct flow of the water through the sprinkler. Although the rotary sprinkler is the most commonly used on golf courses, various types of sprinkler heads may be used for different situations, including around green surrounds, or in this case around a bunker. To produce the optimum water distribution, sprinkler heads should work at the correct pressure to give a uniform distribution pattern radiating away from the head. In this schematic, the sprinkler is working at the correct pressure, producing a wedge pattern in water distribution. In other words, the further away from the sprinkler head the amount of water delivered decreases linearly. If the pressure is too great, uneven distribution occurs, due in a large part because the water droplets are too small and susceptible to drift if the pressure is too high. Thus the distribution pattern becomes more random. Conversely, if not enough pressure is present, large drops are produced that tend to be distributed unevenly further away from the sprinkler. Proper sprinkler spacing should produce an overlapping water distribution pattern, oftentimes referred to as a head-to-head distribution. Schematically, an uneven water distribution occurs when one sprinkler head throws water to the next, and vice versa. In designing an irrigation system, the ability to apply the necessary amount of water is influenced by evapotranspiration, or as is commonly called ET. ET is comprised of the transpiration of the turfgrass plants and the evaporation rate of the soil. ET rates are influenced by wind, temperature, air humidity, radiant energy, and the soil's water-holding capabilities. If not enough irrigation is applied, dry conditions can be produced. And if moisture stress is severe enough, turf loss may occur. Although not enough water can cause turf stress, the most common problem associated with irrigation, especially in humid temperate region, is overwatering. A popular saying is that 50% of the golf greens are overwatered. This photograph is rather unique in that it was taken from a moving triplex greens mower. Notice the water being pushed up. In replenishing lost soil moisture, irrigation needs to be applied to account for soil infiltration rates. In this case, the water was over-applied or at a rate that caused ponding. Multiple irrigation cycles may be needed to match the watering rates with soil infiltration rates. Agronomically, overwatering increases turf injury due to wear, causing a loss in turf density. Moist conditions and thinning can lead to disease problems and an invasion of weeds like poa annua. In this instance, thin turf and wet conditions has led to algae invasion. Algae conceal the soil surface, leading to turf decline. During high temperatures during the summer, excessive irrigation or untimely rainstorms can cause saturation to the soil, contributing significantly to turf loss. Determining if and how much water to apply is dependent on many factors, including monitoring weather patterns and checking soil moisture conditions. Root zone moisture levels can quantitatively be determined by checking dew patterns and using soil probes. Soil moisture levels can also be determined with soil moisture sensing devices, and the use of visual wilting signs can trigger water applications. We will look first at monitoring weather. Modern irrigation systems have the capability to monitor local weather and turf conditions. For example, wind speed, air humidity, and temperature, along with soil temperature and moisture levels, are often measured. These measurements can be communicated electronically back to the computers and analyzed to determine potential water loss and the need for irrigation. Keeping track of weather patterns is a daily ritual. Several weather monitoring services are available that can provide real-time weather reports, along with cable television channels. In addition, real-time weather reports can be found on websites located on the Internet. On golf courses, signs of moisture stress include checking dew patterns early in the morning prior to mowing. Dew forms from both the condensation of water vapor in the atmosphere on the leaf blade and guttation water pushed through leaf openings called hydrothodes due to the buildup of water pressure in the root system. The presence of dew is an indicator soil moisture is present, while the lack of dew is an indicator of some degree of moisture stress. In this photograph, the plots containing dew have adequate moisture present in the root system for the turf to get through the day with minimal moisture stress, while those lacking dew lack soil moisture and will most likely suffer moisture stress in the form of wilting during the day. Notice too that the amount of dew present varies. In this photograph taken on an early summer morning, dew was present in patches, but many areas or spots lack dew and actually show early signs of wilt denoted by the bluish color. In this situation, additional water was applied during the day. Soil moisture levels are often checked with a soil probe or a similar type of device. Once a small soil core is removed, qualitative moisture levels can be determined by color. If moisture is present, the soil, or in this case the sand, is a darker color. Also, by rubbing the core in your hand, the core should feel moist. If it is dry or crumbly, water will be needed. Although not widely used, soil moisture sensing devices are becoming more popular. These portable devices are becoming more affordable and provide a quantitative measure of soil moisture that can be correlated through the use with turf quality. A visual indicator of moisture stress is the presence of wilt. As previously mentioned, wilt appears as a bluish color, and oftentimes footprinting caused by the lack of turgidity in the plants is an indicator of moisture stress. Wilting is most obvious in early to late afternoon. Wilting can occur across large turf areas or more isolated areas as shown here. Where the most of this fairway is green and appears to have adequate moisture, along the edges wilt areas are appearing that will require water. In this case, wilting appeared along a narrow strip of turf between the green and bunker. In many instances, the areas on a green or fairway that require water are not uniform. Although turning on a single or series of sprinkler heads is common, the risk of overwatering areas that do not require water is a concern. Hand watering, although an intensive, labor expensive, and sometimes annoying practice to golfers, if done by qualified individuals, can provide a firm, fast turf by providing water to only those areas that need it. There are several types of nozzles that can be used in hand watering, with various patterns and volume of water delivered. A majority of irrigation systems provide quick coupling valves for the purpose of hand watering. Some superintendents have adjusted their irrigation system, as well as manufacturers are now developing means to turn pop-up sprinkler heads into quick coupling units. That has allowed for hand watering. In many instances, superintendents will add quick coupling valves to the irrigation system. Another watering practice is syringing, which is a very light application of water to the turf. The practice may consist of turning on a rotary sprinkler briefly or by hand watering. Syringing can be hand watering, but not all hand watering is syringing. With syringing, you are not attempting to make up a moisture deficit. It is practically usually done in late morning or early to mid-afternoon for the purpose of cooling the turf during periods of summer stress to minimize any heat stress that may occur. As a side note, a watering practice not related to maintaining turf is watering bunkers. With improvements in bunker construction, including better drainage, and synthetic materials that hold the sand in place, for example around bunker faces, as well as lining materials that reduce silt and dirt migration into the bunker, combined with better sand materials, the bunker sands tend to become dry and will literally slide down the faces. Increasingly, golf course superintendents have had to keep the sand moist to reduce the potential for sand movement and also enhance the playability of the bunker. The quantity and quality of water available combined with proper programming is one of, if not the, most important agronomic issue facing golf course superintendents. An understanding of the factors involved in developing an irrigation program will produce the desired turf health, quality, and playability demanded by golfers. And finally, for those where freezing temperatures can occur, don't forget to winterize your irrigation system.